All right, we're continuing off of here. Last time we did this, we're going to do a bounce question, and then we're going to go straight into arc. I'll explain why RK3 and RK4 is very powerful. The reason why is because it can do imaginary. Because if you look at the stability, it goes into the imaginary domain, which RK2 it cannot do. Yeah, and probably we would also talk about CN if possible. Yeah, I think that's the plan. Yeah, I do want to mention for engineering, there's a few things I do want to mention before we begin. So this is what I did a long time ago, and basically, I still recommend you do it. Basically, you go into your university website and check out the specs you need for a computer for that university. Is what I did in the past, and it worked out pretty good in my opinion. For yeah, I recommend that. That's how I chose my computer basically. I basically looked at the stats for my university and done it, and that will help you choose which computer to get. Hello there. So again, let me see if my camera still works. It's gonna be lagging a little bit. So next portion of this is gonna be a classic question I got as there's gonna be a wall somewhere. It's gonna be bounced off. Ah, I think I never did this with a computer. I think I only have it in basically the mechanics form. So we're just gonna do some inter mechanics problem into computer, and it'll be much easier because we're gonna use what was it called again? Coefficient of electricity or energy or something to bounce off a wall, and it'll be cool. So I started doing this a little bit and got something, and we're gonna get there. We're gonna get to the hard things, but let me turn off my camera so we can start. Yeah, I was testing a few things. Let's just begin like this because why would I want to? I want to show the whole process, right? I don't want to just show like one process and that's done with. We're gonna show the full process, and we're gonna have to teach you about what was it again? I think it was called elastic bouncing is a perfect. There's a perfectly elastic bouncy, but there's a loss of speed after impact. So we're gonna have to get something called, I believe it was called coefficient of restitution for wall bounce, which it depends on the material of the wall, but we'll do that later. The main point I want to bring out is import math and why it's important. We're gonna bring that up like crazy, and first thing we're gonna do is basically copy and paste this over here. Because why not reuse assets from before? There's no reason for you to not reuse assets. Always reuse assets whenever possible. I've reused many assets in my library that in my code that I just copy and paste continuously. Like, and with that said, x0 equals 0, y0 equals 0. And then we're gonna copy paste again because over here we have a perfectly good system over here. So unlike last time, we're gonna use the math version of it just for fun. It should still be 100% okay. Um, Either way, it would be fine. I just wanted to use the math version this time, because we are going to show you a little bit of the power of the math version. So the thing over here was that we had to get integers. This is an incredible little point that I didn't tell you last time. Well, this numpy, if you were to do this non-integer, let me just say like 0.1, watch what happens. It has an error. Yes. So there is a limit to this. Always was. I just never explained it. Never showed it off until now. So this is where we're going to fix that limit with this over here. We're going to fix this limit by using the math definition. So what does that entail us doing is basically just put a decimal in there. So we're just gonna put something like I don't know, 456 point there. We're gonna multiply this by give me a multiplication, which is gonna be mat what was it again dot pi, and it's gonna be divided by 180. And you see by the check mark, this is okay. This is an okay code base. Look here, so the check mark. And that's basically the whole point of this. I want to showcase mat, the import mat, why you would use import mat. And that's it. Yeah. And obviously I need to do some basic thing like I don't know, x equal np dot because the position of the variable is the same. Yeah, there wouldn't be any difference. And honestly, why not just be lazy about it? And do I want to do it this way? Yeah, let's just be a little lazy over here and do it like bracket bracket. And then this bracket would allow us to just showcase it much easier, and it'll be faster to do it this way. Yeah, there you go. With initial variables decided. And the next thing we're going to do is basically we're going to do for I in range of parentheses I, comma, length, and this will be parentheses t. This is a for loop, classic for loop, basically. And then this will be we're going to do a first velocity update, which we already know that Vx will be the same. Like it will generally be I, and this will be equal to Vx block. It would be I minus 1. And yeah, wait, we made a mistake. This should be 1. There's an infinite definition there, which is not right. Then it's Vy, and then there's going to be a bracket I. Obviously, that's going to be I, which is equal to Vy. And it's going to be bracket, and it's going to be I minus 1, and it's going to be multiplied by dt. No, minus g dt, like last time. And then that's it. And then, actually, why am I doing it by hand when we already have the same thing over here? I don't know why I was, yeah, I don't know why. We'll just be copying and pasting that over here, and we have it. Oh. The index is wrong, but we can fix that very easily. As you can see, it's J is and it should be in this index it should be I because that's the one I chose. Because there's no second for loop for the data. Anyways, so next thing I have to do is if parentheses I bracket I is greater or equal to the wall. Where's the end wall? Did I? Oh, I never explained it. Okay, there's gonna be like a x underscore where the wall exists, which we can just define as 5 because it would definitely hit 5 from the estimate above. So if it's bigger than x underscore wall, um, and well, we have to make sure that it's v x, and then we do brackets I is greater than 0, and then we can end it and we can tab it over here. So if x, well, I equal wall, right? So this will not always be true, although, right? But we need to make sure that we have a negative velocity, so everything changes to negative. And then we have to leave the velocity with e, because that is the classic way to look at the whole entire question. So what has to happen is v has to flip. As you know, this vx over here, I, has to flip into a negative direction, which is classically in mechanics just negative e multiplied by vx, bracket by I. What this does is it's a one-time thing that happens, and it's basically just a bounce that happens. And that's basically it. There's nothing magical about it. It's just a bounce that is happening. And we probably should notify that it has bounced, but yeah. Anyways, it's just a bounce. Um, okay. Um, all right. So next is if velocity hits the ground is next. Oh. So last time I did a break, but in reality, if you want to do something actually like it will do something, you need to do this. Basically, you're gonna do a VI, like the same thing. I'm just gonna copy and paste. Why am I not copying and pasting? This thing actually no, that's the and I don't want to index again. So we're just gonna lower to 0. Oh, right. Is it 0 or yeah? It should be 0, and then we'll make it less than because we can, because we want one more index, and we'll just do this. And I think there's an error here. This 4, I think. No, this if I think has to have this. And this 4, I think, also has to have this. So yeah, there's a bunch of errors. I don't know why it says okay. That's definitely not okay. And then we'll do tab y bracket I equals 0. Start breaking because last time I noticed something a little problematic with this. There's a line over here. I mean, you know, is it this parentheses I haven't put down? There's a problem here. It's gonna take me a long time to figure out. Yeah, there's indent. Oh, I'm so stupid. I apologize. There needs to be indent here, obviously. I was wondering what the problem was. Okay, there we go. It's supposed to be break. Anyways, we're gonna make it inclusive, which is just by doing this. I plus 1, and then it's gonna be y, x, y. What this does, if I remember correctly, it takes element 0 to I, discard everything after I, basically. And basically is what happens. Yeah. And then we do this, we have this, we have this, and then we were just gonna continue this again. Yeah, and then it's gonna be like this, I plus 1, and then I somehow made a space there. And with tab, vy equal vy bracket, this will be I plus 1, and then it'll be I equal t bracket uh, I plus 1. Unless I made a mistake. Oh, please, I didn't make a mistake. I did make a mistake. And I'm so happy there's Jupyter Notebook to tell me I did something wrong. What is the mistake here? Don't know, actually. No, it seems about... Oh, yeah, over here. Last time it didn't have that problem because it was, yeah, it's always a debugging that takes a long time. All right, now we're going to break this. And we're going to plot this. And we're going to do a plot, p dot d, and you can just do figure. And then we can do this figure 1. I mean, there's many ways to do it, but this is one way to do it. And we're just showing off many different ways. Plt dot plot parentheses because you might have to label it plot 1 or something. Anyways, x comma y and comma we'll just parenthesize it for now. I just need to make sure it plotted correctly. Oh, it did it! Look at that! Look at that! It plotted correctly. So this allows us to now adjust it over here. If we want, we can make a bigger e. Where is the? I know I put it here, right? Wait, don't tell me that this e is never being used. Oh wait, is it? No, it should be. Did I forget? Wait. I need this. There we go. How did E work without me? Oh, it's because I was playing with it a long time ago and had E. But I need to make sure this E works now. Um, yeah, it works. Okay, now we can do all the figure stuff, which is I am just going to be lazy and just take it from here. Where was the good one? Yeah, here it is. All of these things. I'm just gonna take it. Thank you. And doesn't really need a legend because yeah. So now we have done it. And if you want to be a little bit more fancy, there's a few more things I'm going to show off over here. Grid, and you can do a true over here. And it would, did I do this wrong? No, I did. I didn't press T over here. True. There we go. More cool things. Let's just do like if this is one. Where is one? The max it can go is one. So I just want to show off what happens one. You still um loses energy because it's five over here and it's near top. But let me just change that wall parameter to one and see something cool. Boom! Yeah, now this is really cool in my opinion, because if you think about it, this shows you this is basically a trajectory where you hit a wall and it booms back, and this is like a basketball. If you have a basketball like in a wall, you just shoot and it goes off, right? And it shows kind of like a trajectory over here to this point. Now this is not accurate. The air resistance will get I believe it's 6 pi a something, that's Stokes flow or something that happens. But anyways, it's very cool, isn't it? I find this entertaining. And you can play with these parameters. Just so you know, all code does is in my Discord. So if you want to check it out, you can. And then this is the code over here. I know you can also do it yourself. I mean, it's not hard. Anyways, I'm gonna stop the recording here and then move on.